Welcome to the University of Michigan Dentistry Podcast Series, promoting oral health care worldwide.
Since the beginning of civilization, man has relied on tools to make our lives easier, more productive, or more pleasurable. During this century, a tool has been invented which will have perhaps the greatest impact of any in history: the computer. We depend on it to find solutions, make predictions, render designs, and store and retrieve information. With our extraordinary use of this tool has come an explosion in job opportunities in the computer science field. Since it is such a young and growing field, women are creating and enjoying the opportunities in the field right along with men. And right now, the U.S. government estimates that over 27% of the computer professionals in this country are women. Most new graduates with a bachelor's degree in computer science begin their career as a computer programmer. A programmer gives the computer data and tells it what to do. Bonnie Hausman is a scientific programmer for the National Oceanic and Atmospheric Administration. Bonnie began her career as a clerk for the agency with no college education. She became interested in computers when she received a promotion doing data entry, and she began her college studies in math and computer science. Since her graduation from college, she has taken physics and other science courses to help her in her work.
Basically, the work that I get involved with is modeling the upper atmosphere, which doesn't sound, like anything real exciting, but it's amazing how little we know about our world. We do know that there's a link between the sun and our weather, but we don't know what it is. Of course, we don't know what's going on up there. And hopefully one day we'll be able to say, okay, we've had a solar flare. That means that 1 week from today, you will probably be having rain. But until we know the physics involved, until we know how things work, we can't do that. The scientists collect the data, and we take it and try to make some meaning out of it, I guess. Modeling is mostly a mathematical process. We take what data we have, we take real life, that we know in a certain particular position, and mathematically we sort of project out. It's not always physically true, but what it does is it tries to take one single event and say, okay, what happens from here to here when you've only got one point in the middle? So what we're taking is little sets of data, and we're trying to project what happens throughout the whole world. A lot of times you're taking really enormous data sets, and you're trying to distill them down to what they really are. And if I could give you back a picture of what they are, it's much more meaningful.
Although there are many jobs with the government, most computer scientists will find themselves in business and industry. Many women who start as programmers move up the ranks to the next position on the ladder, a systems analyst. A systems analyst designs programs to solve problems and then instructs the programmer on how to carry out the design. Linda Benson, a systems analyst for Wells Fargo Bank, gained experience as a programmer and senior programmer before taking her present position. Linda has a bachelor's degree in computer science.
Most of my time is spent at my desk, analyzing data, writing specs, writing programs, debugging on the terminals. Sometimes my day may consist of only designing programs, and I may not program at all. And there may be several months where I only design programs, and there may be several months where I'm working on the terminal. It varies in where the project is. And like for 1 year, I never even touched the terminal. My department has designed the IRA system, which is the retirement products and the IRA accounts. Because what would happen is, for example, that you've decided you want to set up an IRA account. That account would go on to the system that I work on, which would be one record within that system. I have been disabled since I was 2 when I had polio. I have walked with crutches since I was 2. I feel I'm a pioneer. I feel I'm a pioneer in many ways. I'm a pioneer as a disabled woman out in the world and participating in life in all forms. I feel I'm a pioneer because I'm one of the few women in the field. I love my job. It is creative, it is exciting, it is innovative, it's challenging. It gives me an opportunity to solve problems. We've been working many, many hours. One of the things about being a computer scientist, it is not necessarily an 8-to-5 job. A computer scientist may be called in the middle of the night at 12 a.m. if there's a problem and must immediately go in. A person isn't called just like a doctor. That's how important computer scientists are.
Many handicapped individuals, like Linda Benson, have found computer science is a good career choice. Not all computer specialists in business and industry stay in programming. Many move into management or sales. Sharon Schmidt moved from systems analyst to data processing coordinator. Now she is in sales for NCR Corporation, where she works on a team that sells million-dollar computer systems to banks. Sharon has 2 master's degrees, one in computer science and another she obtained recently in business administration.
Having been a systems analyst and a data processing coordinator, I think that technically I'm very well prepared for the kind of job I have now, because I know how to speak to a customer. I know how a computer works. I know how terminals work. I know a lot more about the actual data processing environment than a lot of other salespeople. My job primarily is to manage an account, and I work with the financial industry. So our clients are the major banks in Northern California. What we do is try to see an area in a bank where they may need something we have, and we sell solutions more than anything else. We try to go in and show them how they could save money in, let's say, in operations by using a certain type of equipment. And by showing them, you know, like if you can save this much money over so much time, or you can have return on investment is done in 3 years, they're more likely to listen. So you really have to know the situation in a bank. You have to know the equipment and give them facts and figures. I do enjoy my job a lot. It's a lot of work, a lot more work than I ever had anticipated. Sitting back in being a programmer, I always thought salespeople, all they did was take long lunches and go to fancy restaurants and make a lot of money. But they work hard for their money. And it's a lot of fun overall. It's exciting learning about new products before anybody else gets a hold of them. And it's fun trying to figure out a use for them.
While powerful and sophisticated computers are required to run the accounts of large banks, small computers now manage our personal accounts at home. Diane Lyons, a former math teacher with a master's degree in math, has transferred her classroom skills to her home, where she teaches the use of the microcomputer. Diane and her husband David run a school called Data Skills. They represent just one way the flexibility of computers allows for non-traditional scheduling of work time at home.
Well, we have an enrichment center for children and adults that are interested in increasing their aptitudes or their talents in mathematics and computers. Our curriculum is designed to start with someone who has never even touched a computer. And we sit them down, and right away, the first day that they're here, they're actually working on the computer. They may not be writing programs yet, but at least they've touched it. And for some people, that's a tremendous experience. I work with children. I don't start until 3 o'clock in the afternoon because they're in school. So I help kids with their math. I do some tutoring in mathematics. And then in the evening is when the adults come. And they're here from 7 to 10, and it's even hard to get rid of them at 10 o'clock. They're still here at 10:30, 11 o'clock sometimes because they end up having just as much fun as the kids on the computer. I love my job because I'm working with people who want to learn. When they come here, it's because they want to be here. And to get to work with them, and when it works, and you see the light go on, it's just amazing. I feel so good about myself, and I feel so good about them, because I know they're feeling an accomplishment. It's very exciting to own your own business, very exciting. Luckily, I have a wonderful partner, my husband. If we do this as a team and as partners, and that's what makes it successful. And working out of your home is neat because I have a small baby that I can nurse and not have it be a problem. I have a 3.5-year-old son who takes a lot of attention, and he is really, I think, benefiting by this.
One growing field today is computer gaming. Most of us are familiar with computer games from television, magazine advertisements, arcades, or personal contact. Computer video games are made up of moving graphics that illustrate battling spaceships or other adventures. A related field, computer animation, also uses moving graphics. However, computer animation is usually more sophisticated in its detail, and so is used in films and television for special effects. Pat Cole works for Atari Incorporated, a company that designs and builds computers, computer programs, and video games. Pat worked previously in feature films for Lucasfilms, designing special computer animation segments for the movie Star Trek II: The Wrath of Khan, and other projects. Pat has a master's degree in applied science.
Well, I am software manager here at Atari of a group called Special Programs. I'm sort of right now second in command to the boss of Special Programs, Steve Wright, who's the director. And he hired me primarily because he needed more management support in this group to coordinate all the projects and to just be involved in all the daily activities, coordination and budgeting and planning and interfacing with all the people and scheduling, all of those different management sorts of activities. But he also was interested in my background, which is computer animation, and a lot because there's a very strong interest in Atari in doing computer animation. In conventional animation, people draw outlines of some little character and pencil test them, and then there's a whole crew of people that by hand draws all the in-betweens and colors the cells, and eventually it's recorded on film at an animation camera. In computer animation, the images are generated by the computer under control of programs that people wrote. But one thing that the computer brings to the table is that it can do for you a lot of what would be very tedious and menial for somebody to do by hand. You can program the computer to know about 3 dimensions, and the computer can figure out where the light is, where the shadow ought to be. It can calculate perspective for you so that the picture looks like it's 3-dimensional. And once you get that database in the computer, you can also program things like camera moves, and you put them all together and the computer makes pictures that you film, and voila, you have animation. A typical day for me is pretty hard to define, and that's one thing I love about my job here at Atari, is that I have so much variety and so much flexibility in what I do every day. In the back of this building, we have a whole laboratory area that's full of computers and people working, and I'm constantly back there working with the people. Sometimes I'm just sort of walking through, seeing if there's anything I can spot that, you know, is a sign of progress or a sign of a problem. And other times I'm actually back there working myself. For example, one of the favorite projects I've had since I've been here at Atari was working on Superman 3. And I'm interacting with directors of movies and with the programmers and with management people and with marketing people. What I'm really motivated by is waking up in the morning and feeling the magic and wanting to go to work and looking forward to it and realizing that as I drive along in my car on the way to work, my mind is turning about something I want to try or something I want to tell my boss or an idea I have to change something. And that excites me a lot more than the money or the title or any of those things.
Computer technology and application are growing at such a rate that we can hardly keep up with them. New breakthroughs are announced every day. Research is a rich and challenging area of computer science. Dr. Elaine Kant is an assistant professor of computer science at Carnegie Mellon University and conducts research in the field.
So my research is a form of artificial intelligence. Artificial intelligence is kind of a big name for just getting computers to solve problems, because really what intelligence is all about is solving problems. And there are some techniques that people use for solving problems that computers can use too. What I work on basically is trying to make computers easier to talk to. And right now, to tell a computer what you want it to do, you have to write a program in a special language that computers understand. I'd like to make it so that you only have to tell it what you want it to do, not how. Right now you have to go into all the details about how. Okay. Well, suppose you wanted the computer to add the numbers from 1 to 100. Okay, what I'm trying to do is make it so that all you have to do is say, add the numbers from 1 to 100. All right. And what the computer then has to figure out is all the things that normally a programmer has to figure out. It has to decide how to store the numbers, how to represent them inside the computer. It has to then know that it's going to go in a loop. It's going to start with 1, add another one, say we get 2, add another one, say we get up to 3, and has to decide when to stop, has to test that it's reached 100. Okay, and doing all those sorts of things, like going through a list of items till you get to the end, is a pretty standard thing that people do over and over again when they write programs, and there's no reason the computer can't know how to work out all the details of doing that. I like my job a lot. In fact, sometimes I think I get too carried away. And last night, instead of going to bed early, since I had a lot of things to do, I stayed up and just kept trying to get this one thing to work. And I think one reason computer science and programming in particular is very rewarding is that you get to solve lots of little problems. When you get just one little part of your program to work, you feel like you've accomplished something, and you can see it happening, and it goes off and thinks and either prints a picture for you or comes back and responds to you in some way. And that can be a lot of fun.
Although computer science is a challenging and time-consuming career, many women computer scientists are able to successfully combine a career with a family life. Many working mothers rely on outside help, such as child care centers or full-time babysitters. And household responsibilities must usually be shared in a two-career marriage.
It's hard at first to get over the idea that you're supposed to be a superwoman. I was supposed to have a career and come home and keep an immaculate house and cook 5-course meals. And the worst part about that is my own expectation. Bill never expected me to do this. And I was a frazzle, coming home, hurrying around, trying to cook dinner and clean the house. And I really felt resentful. I really felt very angry. But finally, when Bill and I talked about it, it dawned on me that it was not his expectation. It was mine. So basically what I did is decide what's important to me. Clean house is important to me, but I'm not willing to put the time into it. So it's better for me to pay somebody to do it.
I support Bonnie's career, mostly because she is her own person. It makes her a more interesting person because she gets to go a lot of places and meet a lot of different people that I don't. It also is just a lot more fun.
It's very challenging being a mother, a good wife, and being a good teacher all at the same time in the same atmosphere, because sometimes all three things are happening at the same time. So there's all these people kind of pulling on me at the same time. Luckily, I have a lot of energy and I have a lot of patience, so usually I can handle the situations. David has always been one he loves playing with the kids, and he'll take Josh with him on an errand, and David loves to be in the kitchen. If the house needs to be vacuumed, he'll do it. He's a man of all trades, and he is not embarrassed to take on jobs that normally we think of the wife doing.
Mm-hmm. About 3.5 years ago, I had a major decision to make. I was offered the opportunity to go into one of the state-of-the-art laboratories for my chosen field, Jet Propulsion Lab. The problem was that took me to Pasadena, California, and my husband, Randy, was in medical school at the time. It was a big decision to make because the kind of things I wanted to do weren't nearly as available or at such a sophisticated level on the East Coast. And yet, it's not easy to just uproot from medical school and go somewhere else. So Randy and I talked a whole lot about what this would involve. And I think partly we went into it fairly naively. I moved to California, and we maintained 2 households. It was never a separation in any sort of negative sense. It was always just a matter of time until we were back under one roof. And he finished in medical school at the top of his class, and I got very well established in the field of computer animation. And almost a year ago, he graduated from school and joined me out here.
These women are all bright, inquisitive, and creative. 3 characteristics of a successful computer scientist. They also all share one important skill, the ability to think logically. Most of them have had an extensive math background, which helps develop logical ways of solving problems.
I recommend that you get as much math as you can. Algebra and advanced algebra. For sure, get a taste of geometry, trigonometry, and calculus. If you can get calculus while you're still in high school, it'll be such an easy transition for you to go into college, because the college atmosphere, they leave you on your own.
So when I finally decided that I was going to go into computers, and I had to have math, remembering back to all the high school experiences, I went through the same, here we go again. I think mostly the fear was of failure. I was afraid that I'd get in there and I wouldn't be able to do it. So what I did was really probably a very smart thing, although I lucked into it. I started out taking a very basic algebra class. And somehow some of the things were with me still from high school, and I found that I could do pretty well. So after that, I think it was probably a matter of self-confidence. I figured that nobody else in that class is better than I am. And the fact that I don't catch on to it instantly like the rest of the guys in the class didn't really bother me, because I knew in the end I would understand it too. So I basically, once I got through the algebra class and a couple of calculus classes, I thought, what was the big deal? It's really not that difficult. But somehow in high school you had yourself entirely psyched out that I couldn't do this. I mean, girls weren't supposed to do that anyway. We were supposed to major in languages and English and home ec. So once you get over that initial, oh my God, I'm not supposed to be doing this, it's much easier.
Because the field is relatively young, many people working as computer specialists do not have a college degree specifically in computer science. However, the U.S. Bureau of Labor Statistics advises us that the increasing sophistication and complexity of computer operations will require workers with more and better training. That means most computer professionals in the future will possess at least a bachelor's degree in computer science, business, or computer engineering. Preparation for a versatile, lifelong career in computer science should begin in high school with classes in the sciences and 3 to 4 years of mathematics. Computer courses are also recommended. College students find they usually must attend class between 18 and 21 hours a week. In addition to this, they must study anywhere from 25 to 40 hours a week, depending on the course load. Most computer scientists recommend getting an internship, co-op, or summer job in the field. More information about college requirements and computer-related careers may be found in the brochure accompanying this videotape.
It's fun to, you know, it seems like every day that I do something or I learn something more, I get more and more interested in computer science. You know? But now that I learn more about it and I see what's happening and I get into my logic and my theory classes and learn things at work, it's interesting. It's amazing, you know, what we can do. It's amazing. Technology is amazing. It used to make me feel really, really bad, you know, because I'm the only black and I'm the only female in the course, you know, and there's a few other females, but, you know, being the only black in the class, number one, and then being a female and all these men, and you're not really on it like the other people, you know, everybody knows their stuff so well. Yeah, it's intimidating. It's very intimidating. But you know, I'm over all that now.
While I was a student in college, I worked quite a bit. I did high-energy particle physics data for the physics department, trying to find the molecular moment of the sigma hyperon, and I also programmed scouting reports for the football team. So real early in the game, I was getting experience, but I was also realizing how broad and ranging the applications of computer science could be. I tabulated data for the Psychological Counseling Center. I did business statistics for the business department. So from football to physics with all those other things in between, I was convinced that there was probably some area of computer science that I would be happy with.
Computer science is a lot of fun. You can fall in love with it. It's a lot of hard work, you know, but you should see the look on people's faces when they come out of that building at 3 o'clock, you know, at night, and their program ran. You know, it's really exciting to see, oh, wow, it works, you know, and you go through it again. It is exciting that you can produce something like this. It's rough, you know, but it's very exciting.
Computer science. It's an exciting future for someone who loves creativity and problem solving. The opportunities are almost inexhaustible. Computers will touch many parts of our lives. Computers will help us learn about our universe. They may help a blind man to see. They will revolutionize the way we do business. The only limitation to the computer's future is our imagination.
The future for computers is really kind of frightening if you try to imagine what it's going to end up being. Right now, personal computers are really quite the thing, and they may start out as being a simple little tool for Johnny to help him get through, you know, junior high school, elementary math. But it's going to become, in the next 5 years, if you don't either own one or know something about it, you're going to be left behind. No field's going to be left untouched.
I think it's just a booming and expanding field. It can be on the level of word processing, which doesn't require a lot of math or technical knowledge, on up to applied physics and very sophisticated research. And I think that in some way or another, there's a little bit of room for everybody.
You've been listening to a presentation from the University of Michigan School of Dentistry, which is dedicated to supporting open learning and open educational resources. This recording is licensed under the Creative Commons. It may be reused and redistributed for nonprofit use. Please attribute materials to the University of Michigan School of Dentistry and redistribute under this same license. For more information on how this and other University of Michigan School of Dentistry recordings may be used, visit www.dent.umich.edu/license.